Okay, so let me just try to explain. Okay, let me try to explain why solving. I don't really have the possibility of using my computer, so that's why I'm using my phone. All right. So let me read. A particle moves in a straight line with retardation 4 plus v squared, where v is the velocity. The particle is initially at the origin with velocity 2 meters per second. At the origin with the velocity 2 meters per second. Okay, show that its displacement from the origin when it first comes to instantaneous rest is halved in 2 meters. So this is just the application of calculus. All right. So now we have the retardation. Okay, and we know that normally the retardation has a relationship with the acceleration. Retardation is like deceleration. Okay, so retardation is just negative acceleration, as well as acceleration is negative retardation. So I need to relate my velocity alongside with my acceleration. So we know that the acceleration is normally equal to, sorry about that, let me try to insert a text box so that you can easily see clearly. So normally we know that normally the acceleration is equal to dv by dt, right? That's the acceleration, dv by dt. Now acceleration being equal to dv by dt, what then do we have? Now if you come back to this question, you realize that we have no relationship with time. The acceleration given to us in this case is in terms of v and not in terms of t. Now furthermore, we are finding the displacement, so we have to rewrite the acceleration to be in terms of the velocity and the displacement, so we remove time from the equation. Okay, so now we also know that, so this is going to give, what is the velocity? The velocity is ds by dt. Okay, ds by dt. ds by dt. Anyways, let me just simplify. The acceleration is also equal to v dv by ds. That is it. So the acceleration is also equal to v dv by ds. So this is the acceleration in terms of the velocity and the time. So we are going to use this second formula because we have ds and we have dv. We don't have t. And the equation we have the acceleration, we have the velocity, and we need to find the displacement. So let's move with that second formula. So my acceleration, like we have our acceleration, that is, we are going to use, like I said, v dv by ds will be equal to, now it is negative the retardation. All right, so I'm going to put negative into 4 plus v squared. All right, that is what I have. Okay, from here I just need to separate variables and integrate and find my velocity or my displacement in terms of my velocity. So I will divide both sides of this equation by 4 plus v squared. Okay, I will divide both sides of this equation by 4 plus v squared. Then later on I now have to multiply by ds. Okay, so I'm going to have, on the left hand side I will have v dv, sorry, v dv divided by 4 plus v squared. I'll just keep the negative sign on the right hand side, then I'll multiply by ds. So I'm going to have negative ds on that side. Okay, now the next thing to do is I'm going to integrate both sides because I've separated my variables. I'm now going to integrate both sides of this differential equation. If I integrate both sides, I will have the integral of v dv, sorry, the integral of v dv divided by 4 plus v squared equal to negative the integral of ds. Negative the integral of ds. Okay, now from here you realize that the right hand side is very easy to integrate. We are just going to have s, negative s actually. Now the left hand side, we can identify that, okay, if we let u to be equal to 4 plus v squared, right, you realize that our du will going to give us 2v dv, okay, which now means that our v dv our v dv our v dv will clearly be equal to v dv will be equal to du divided by 2. Okay, now from there, I think things are now easy to go. From there, we just have to replace back. Okay, so from there, the left hand side now becomes the integral. Now in a place of v dv, what do we put? We put du divided by 2. Then, so this is du. I'll just put a half outside because when we are dividing by 2 is equivalent to multiplying by half. Now my denominator is just u, okay, then equal to negative s, then plus a constant of integration. Okay, now from here, what do we have? You see that if you integrate du on u, we have ln of the absolute value of u. Okay, ln of the absolute value of u. Then my u is 4 plus v squared. So that's why when I integrate the left hand side, I just get half. If we integrate, we are going to have half the ln of 4 plus v squared equal to negative s plus the constant of integration. Now we need to find this constant of integration. Okay, so let's go back to the equation. It said the particle, let me highlight from here. The particle is initially at the origin with velocity 2 meters per second. Now we know that at the origin, your s is equal to 0 and your v has been given as 2 meters per second. Okay, so it's now easy for us to move. So my constant of integration k can now be easily gotten. All right, so you realize that from where we have our k will just be equal to half the ln of 4 plus 2 squared, because I'm actually replacing my v with 2. Then now I'm going to add s. My s is just 0. Okay, so it's just like equivalent to not even putting it. So yeah, 4 plus 2 squared is 8. So my k is equal to half the ln of 8. That is my k. So from here, what do we have? From here, we can now just easily find, we can now replace k back into our equation. All right. So if you replace k back into the equation, we are going to have half the ln of 4 plus v squared equal to negative s plus, what is k? K is half the ln of 8. Now from here, I'm just going to subtract. I will multiply all through by negative. This man is going to be positive, this man is going to be negative, and this man here is going to be negative. All right, then I'm going to add this quantity on both sides of the equation. I'm going to add oh, sorry about that. Now when I do that, I'm now going to add this my k on both sides of the equation, so that we are going to have our s directly. Okay, so if you do that, you realize that your S will be equal to half the ln of 8 minus half the ln of 4 plus v squared. Okay, now we are just going to use indices to bring these two guys together. So since half is common, finally we are just going to have something like 8 divided by 8 divided by, let me first of all wipe this part, 8 divided by 4 plus v squared. All right, so we have 8 divided by 4 plus v squared. That is it. Voila, that's our final response. Now the question is asking us to show that its displacement from the origin when it first comes to instantaneous rest is half ln2. So when it comes to rest, you realize that your final velocity is 0. When it comes to rest, then your v is equal to 0 meters per second. Okay, so with that, all we need to do is to find S, the displacement, when it first comes to rest. So doing that, your S will be equal to half the ln of 8 divided by 4 plus 0 squared is just 4. Okay, so if you simplify, you're going to have half the ln of 2 meters. So we are done with the proof. Okay, thank you guys for watching and see you in the next video.